In the first 3D map question video, we outlined a very simplistic solution showing how to bind 3D objects with UI elements strictly using the simple bind components without any backing data models or MV-star type solutions. In this video, we will be showing another more complete solution to the same question by using a model-driven approach with dynamically created UI elements. We will be taking advantage of many of the features currently in Simple Bind, including binding to a binding context, items controls in world space, use of a list box control, value converters, and event bindings. There is a lot to cover in this demo. Because of that, I will not be starting from a blank scene, but instead walking through each piece of the design and code in an already complete demo scene. To start with this, let's go ahead and take a tour of the demo. When the scene starts up, you will notice that there is a galaxy of planets in 3D space, a list of all the planets in the galaxy in a templated list box, a panel in the upper left corner showing information about the currently selected planet, and some navigation instructions in the lower left corner. Using the WASD keys, we can navigate around the galaxy. The mouse wheel also moves us forward and back. If we hold the Alt key, we can look around using the mouse. Holding Shift speeds us up, and Control slows us back down. You'll also notice that when a planet is selected, it will get a colored ring around it. The data will display in the upper left-hand panel, showing the planet name and its location, and the selected checkbox will appear in the list of planets. This is planet number 33, and if we scroll down in our list till we get to planet 33, we'll notice it is selected is checked. Each planet is also textured with one of 8 random textures. It has a random world location and also has a random spin speed. You will also notice in the list of planets that some planets are marked as in view. This is a value bound to the planet's mesh render is visible property. The renderer will render items that are close to the viewport but not actually visible. So this may show a planet as in view when in reality it is still slightly off camera. However, it still shows a valuable binding behavior. As we zoom out, you will notice that more planets become in view. If we select a planet that is not currently in view, the camera will automatically look at that planet. You'll also notice that when there is no planet selected, the details pane in the upper left-hand corner will not be shown. As we select each planet, you'll notice that the data appears as we would expect. That completes the walkthrough. Now let's get to how the demo was put together. The first item that we will take a look at is a very simple architecture diagram of the model, behavior, and game object layers. If we take a look at the middle of the diagram, we'll see that there is a map, app, game object. This is the entry point into the Unity world for our model and has a simple map app mono behavior attached to it. The map app script will use a map generator to randomly generate a map of randomly generated planets. Each of these are simply standard C# classes that can be used to represent any mechanism by which you would load your model data. In the Unity side of the application, there are 2 separate pieces. The UGUI, which contains the canvas, the planet list, the selected planet, and all the planet items, and the 3D world, which contains a map and all the planets in our model. If we switch back to Unity, we will notice that the hierarchy is laid out very much the same way. We have our map app with our map app script, a map object, which is a basic transform with an items control, and our canvas. And our canvas has the planet list, the selected planet, and also the instructions. What you will not see is any existing objects for any of the planets that we will create. Let's go ahead and take a look at the map app script and the models that we will need. If we open up Visual Studio, we will see that our model consists of the map app, the map generator, a map, the planet, and also some event arcs. If we start at the top with our map app, when it starts up, we're going to create a new generator. We're going to ask the generator to generate a new map of 50 world units in all directions with 100 planets inside. We're going to go ahead and grab the first planet after that map is generated and go ahead and select it. And then we wire up a couple events that we'll take a look at in a little bit. If we look at the map generator is fairly straightforward. It takes in our size, number of planets we want to create, creates a new map, walks through the loop, and just generates a new planet for every item that we want and adds them to the planet list. If we look at the generate planet mechanism creates a new planet based on the ID that we passed in, simply names it planet plus the ID. We choose a random color, which as you can see here is one of these 8 colors. We choose a random rotation speed by simply choosing a random number between negative max rotation and max rotation, which was set as a constant right here as 30. We also choose a random material name. And for this demo, we're using these 8 different materials, which can be found on the Unity Assets Store for free. And we just choose a random one and assign it to the material name. We also grab the location as a random between negative max size and positive max size in all directions. Then we simply return that planet. If we take a look at the map object, you'll notice it is very straightforward. It has a list of planets. It also has a public property, which is a planet called selected planet, the 2 events that we talked about earlier, and a couple functions. The first function is select planet, so anytime a planet is selected, it can set itself as a selected planet for the map. And this is how we bind to the selected planet information in the upper left-hand corner. We also have a lookout function, which allows items, or planets in this case, to call lookout on the map with a specific location, and it'll raise the event to look at requested, which will tell our main map app that we want to look at a specific location, and it will tell our extended flycam script to look at that location. We're also using the extended flycam script for our navigation. It's been modified slightly, but I would like to give credit to those who created it. Once again, I grabbed this off the Unity forums and slightly modified it for my use here. If we go back down, and let's go ahead and look at the planet. The planet as well is pretty straightforward. It keeps a reference to the map that it belongs to. It has a private isBool, or isSelected property. It has some public properties for ID, name, the select color, the rotation speed, material, and the location, each with a default value. It also has the isSelected property that when it becomes set, it will ask the map to select this planet. It also has an isInView property and basic constructor and a lookout function. This lookout function once again tells the map to simply look at this location. The lookout event arcs is pretty straightforward and just contains a location. But that is all there is to our backing model. We have a basic planet model, planet class, with the properties that we need for each model. A basic map, which contains that list of planets and the currently selected planets, and a few helper functions and events. A generator to generate and load our map for us. And then a mono behavior that allows us to expose our current map object to the Unity world and provide some interaction to other Unity game objects such as the camera. Let's go ahead and switch back to Unity and take a look at how we use that script. Once again, on the map app, we have our map app script. On the map itself, the map is just a basic Unity game object, and it was created from just an empty game object. And we went ahead and we added an items control to it, which is from SimpleBind, and a binding context. The binding context will allow us to bind to values or get data off of our current map. So in this case, we set our binding context to our map app component, and the current map property. The items control is then bound to that binding context, or map object, binding context, and we want to bind to the planets property of our current map. Planets is a list, once again, of planets that we've created. So for every planet in this list, the items control will simply instantiate an item template, set the item template's binding context to that planet, and set its parent to the map object. If we take a look at the planet template, it is simply just a Unity prefab, and it has a lot of bindings on it. The main thing is that every binding or every template that you use needs to have a binding context. The binding context will get set when the items control or the list box instantiates this prefab. It will look for the binding context and set its value appropriately. You'll notice that there's multiple binding behaviors. If we take a look at each one, the first one that we look at is location. So if you remember, our planet had a location property on it, which was a vector 3. We're simply binding that as the source, and the target is the position of the transform. So anytime we change the location of our model, it will update the position of the transform of this object. We also have a rotate script on this planet. And the rotate script simply continuously rotates the planet with some speed in the X, Y, and Z directions. Once again, it takes a basic vector 3 and rotates it as needed. It has a default value of -10 in the X. However, each one of our planets has a rotation speed property on it. So therefore, we're going to bind that vector 3 rotation speed to the speed of the rotate planet script. Once again, allowing each one of our planets to have a different rotation speed. The next binding behavior is selected. In the last video, we talked about the toggle 3D 2D script, which basically allows us to use the mouse to click the toggle on and off a 3D object. We're going to go ahead and we're going to bind this isOn property on the toggle to the isSelected property on our planet. Now this is one of those properties where we want to make sure that it goes both directions, because we can toggle this on and off from both clicking on the planet and also clicking on the list. So in this case, our direction is both. The next binding behavior is for the material. If you remember, on our planet model, we used a material name, a basic string. We want to go ahead and bind that string name to the meshRender.material so that each one of our planets has the correct mesh material rendered on it. In order to do this, we need to convert the string name into an actual material that can be used. What I did was create a very basic string to material converter, which we can take a look at. And it implements the simple bind iValue converter interface, which means that the class must implement a convert to target and a convert to source function. In this case, the only one we really need is the convert to target, so therefore convert to source can simply return null. Convert to target is going to take a string as its value, and it needs to return a material. So in this case, we'll use the resource load with the value to string and cast it as a material. This will load the material up and return it. The final binding behavior on the main planet is for isInView. We talked about this a little bit earlier. IsInView just tells us whether or not the planet is currently visible to the camera. And for this, we're using a very simple technique, which is just to use the meshRender isVisible property. And we want to pass that back to the source. I could have put target as the binding context, but to keep everything consistent, I left the binding context as the source. So for this binding, we want to make sure we set target to source and not source to target. That way the isVisible property, as it changes on the meshRender, will get passed back to the isInView property on the planet object. The other thing that we have on the planet is we have the highlight sprite. The highlight sprite is very similar to the highlight sprite of the last video in the fact that it's using one binding behavior to toggle the 3D 2D isOn to enabled. So it's going to turn that turn on that sprite renderer on and off whenever the toggle is toggled on and off. And if you remember, that toggle was also bound to the isSelected property on our planet model. So therefore, anytime the planet model changes, toggle 2D 3D will change, which will also then go ahead and change this binding as well. The other binding that we added was for the select color. Each planet can have a different select color, which will change the color of the sprite renderer. So we've simply bound the select color to the color on the sprite renderer so that it can update for each planet. And that is our planet template. So if we go back to our map object, once again we have an items control. The items control is bound to our binding context planets field, and the binding context is bound to the current map. And the template that we're going to use for every item in this list is going to be the planet template. So if we go ahead and we run this, and we select, once again you'll notice that the planets have a unique color for the ring, a unique texture. So I'm going to look at a different planet. This texture is a little bit different. Color is different. Speed and rotation is different. Every planet is rotating, different speed, different textures. And it's all being bound dynamically to the correct model in the background. So that's how we created the 3D world. Let's go ahead and take a look at the UGUI side. We have a basic canvas, and on that canvas we start with a binding context. I typically like to set the binding context at the highest level that makes sense. And in this case, everything below it is going to rely on the same current map. So therefore I'm going to set my binding context on the canvas to the current map of map app. The planet list is simply a panel. Let's go ahead and take a look at that. It's simply a panel, and in that panel we have a title up at the top, and we have a simple bind list box. That list box is very similar to an items control, but gives you a little bit more flexibility. It has an item source, which once again is bound to the canvas, binding context, planets property. It has an item template, which is the planet item template. And in this example, we remove the item container. The list box in v0.1 still has a few bugs to work out and has some additional features that need to be added. And for this example, the items container was not needed, so we simply deleted it, and we'll just be using the item template. If we take a look at the item template, a lot of times the easiest way to look at the item template is to simply drag it into the content panel. Now we can actually see a visual of what our item template looks like. If we go ahead and walk through this item template, you'll notice that the first thing is that our template once again has a binding context. In order for any item template to work, it must have a binding context at the root level. This way the items control or the list box or the other data bound controls can find the binding context and set it appropriately. And also, each one of these data templates is just a Unity prefab. There's nothing special about it. The only key piece to an item template is making sure that it has a binding context attached to it. If we look at each one of the properties on here, the first thing you'll notice is that we have a binding behavior as well. The binding behavior is bound to the selected color and simply sets the background color for the image. That way the background is the same color as the planet will be when it is selected. These text fields are simply bound to the properties on the planet model. In this case we have a value ID. Name is bound to name. The toggle in this case is bound to isSelected, and the toggle is on property. And once again this is set to direction of both. Once again we can change the selected value by either clicking on the planet itself or clicking the isSelected toggle. Location, once again is just bound to location to text. In view, the in view is bound to the enabled property on the text. This way, when is in view is false, the text block will be not visible. When it is true, then it will be enabled and it will become visible. Just simply toggles it on and off. The final thing we have in our template is a button, and the button allows us to look at the planet. The button takes advantage of the simple bind event binding behavior. In this case, we're going to bind the button onClick event, which is the standard Unity event, and we're going to bind it to the binding context lookAt function. If we go ahead and we go back to our model of our planet, we'll remember that the planet has this public void lookAt function, which when it's called, we'll call the map lookAt, passing the location of this planet. When the button is clicked, the event binding behavior will automatically call this method on the binding context, which will cause the map lookAt function to be fired as well. And that's all there is to the planet item template. We can go ahead and delete that. And let's go ahead and take a look at the selected planet. The selected planet is what shows our selected planet information in the upper left-hand corner. Once again, it's very similar to the other bindings. In this case, we have a binding context, which is going to be bound to the canvas binding context, which once again was the current map. But this time we're going to use the selected planet property. The binding behaviors that we have here is, once again, we use the selected planet, we use the selected color to set the color of the background image. We also set the image enabled to the value of the binding context. This is a little bit different because in this case we're not using any specific property on the binding context. We're using the entire value of the binding context itself. So in this case, it would be the selected planet value. And what we want to have is that when there is no selected planet, we don't want the image to be visible. And when we do have a selected planet, we want it to become visible. So in this case, we're going to use a null to bool converter, which ships with simple bind. It's one of the default converters. And we're going to use the image enabled property. So if value is null, the null to bool converter will return false, setting enable to false. If any value is set for the binding context, then the null to bool converter will return true, in which case then the image will become enabled. The other two fields on the selected planet information is the name, which once again is simply bound to the name property on the binding context, and the location is once again bound to the location property on the binding context. And those are all the bindings that we have set up in the application. It seems like there's a lot. When we think about it, what we've set up is we've set up a basic items control with a planet template, and we set up a planet list, which also uses the list of planets and a separate planet item template. And all that wiring happens between all the different bindings that are taking place. Go ahead and run the app one last time. Once again, we can select our planets, zoom in and move around. We can use the list box on the side to scroll through our planets, select planet, look at it, scroll in towards it. We can scroll all the way out, see our entire galaxy, select along through the planets. You'll notice once again everything is in view. As I scroll in closer, things go out of view until nothing's in view. I know there was a lot of information in this video, and if you have any questions, feel free to contact us, either in the Unity forums or directly at unity@sfrtsrc.com. Thanks for your interest in Simple Bind, and as always, there will be more videos and features coming soon.